Before we begin the treatment on this letter, we need to test it to make sure that the proposed treatment won't harm it. Because inks and certain sealing waxes can be affected by water, we must make sure that these components of the letter will stand up to washing. It is important to remember that no matter how extensively you test, spot testing is not the same as actually immersing a document in a bath of water. In other words, while testing does let you know if inks will definitely run or sealing waxes will soften, the much greater exposure to moisture in a bath may cause something unexpected to happen. So while accurate and thorough testing tells us a lot, we still have to remain flexible and alert during the washing process. To see if the seal will soften when exposed to water, we will put a droplet of water on a seal fragment and look at it under a microscope. Once we let the water sink into the seal, we can poke at it with a tungsten needle. The seal remains hard and firmly attached to the page. We next blot the drop of water and inspect the seal. There is no apparent change in appearance. Because of this testing, we think that the seal will be safe to wash. The other test we will perform checks the solubility of the 3 different writing materials on the letter. Iron gall inks were generally homemade, and so their formulas vary greatly. In general, they are permanent, but sometimes water will fade them or cause them to run. The blue V was made with an unknown brightly colored ink. We want to make sure this ink won't run and disfigure the letter. Finally, while pencil does not run, a kind of pencil that turned purple when exposed to water was common in the late 19th century. We need to make sure that the pencil on this letter won't turn purple when put into the bath. We always start slowly with solubility testing, so that if there is any change to the ink, it is kept minimal. The first test is to dampen a piece of special blotting paper made out of pure cotton fibers with a little water, and gently touch that paper to the document. We look at the damp paper and ink on the page to see if there is any change to the ink or offset on the blotting paper. If there isn't, then we hold the damp paper to the document for 1 second. If there is no change or ink offset, the contact time can be lengthened progressively. Finally, we want to see how the paper will react to the introduction of moisture. Under the microscope, we put a small droplet of water across a line of ink and let it soak into the paper. This lets us see how quickly the paper absorbs water, if a large amount of moisture will affect the ink, and if the paper is prone to developing water stains when the introduction of water is carefully controlled. Once testing has been completed, with no results to indicate that the proposed treatment will be harmful, we are ready to begin to repair the damage of a century and a half to Sam Houston's love letter.